Okay, so the Unit 3 question, okay, is similar to what we've seen before. This one, we've got to make sure that we're designing this correctly. So, researchers believe that a new drug called Bone Builder will help bones heal after children have broken or fractured a bone. The researchers believe that Bone Builder will work differently on bone breaks than on bone fractures because of differences in initial bone condition. Bone Builder will be used in conjunction with traditional cast. So, to test the impact of Bone Builder on bone healing, the researchers recruit 18 children with bone breaks and 30 children with bone fractures, design an appropriate experiment to determine if Bone Builder will help bones heal. So, when we are working through this question, okay, we have to be designing a proper experiment. So we're going to start by saying how many is in our total group, and that's 18 plus 30 gives us 48 participants, okay, 48 children. And then what we're going to do is we're going to block these kids. We're going to put them into natural groups, okay? Kind of like if you had different grade levels, you'd maybe sort them by grade level, okay? Or sort them by male or female or different athletics, right? So we're going to separate them into two groups. Now, it's not going to be randomly done. We're going to do what's called a block, okay? Block or blocked. Okay, so the first group will be the 18 with the breaks. Let's just put breaks. And then this is going to be the 30 children with the fractures. So once again, we're not breaking their bones or fracturing them randomly. They're coming to us, so we're going to block them into two groups. So 30 children with fractures. Now with each group, because we're testing medicine, what we can do is we can give half the group the medicine that we're testing and half the group a fake medicine to see if the medication actually works. So we're going to say this will get split into two groups. This will get split into two groups, and then will be randomly put into those groups because the more ways you're able to make things random and do stuff like that, it helps with the validity of the test. So that way we know there's no funny stuff going on. So after they were randomly put into two groups, the first group's going to be the bone builder group, and the other group will be the placebo group. Placebo meaning they're getting like a fake pill to see if that helps them too. So how many? We have 18. We'll put 9 children here and 9 children here. So 18 breaks into 9 and 9, and then what we'll do is we will compare the results of the kids that had the bone builder versus the kids that had the placebo to see if the bone builder actually seems to work. And then we'll do the same thing for this group. Okay, two groups, split them in half, bone builder and placebo. And for the bone builder, if it's 30, we're going to try to split this in half to get the biggest groups we can. So we'll say 15 with this group and 15 with this group. And once again, like our top group, after they've been sorted, we're going to compare the results. I could also talk about it being blind and where it could be blind, how you could design it that way. For this case, we're not going to, but we're assuming when it's randomly sorted that this is a blind thing. The kids don't know which one they're getting. Are they getting the actual bone builder drug, or are they getting a placebo that they think is working but not really working? They they should blindly be getting this. That'd be called a single blind. And now when you compare the results, they could who's looking at the X-rays and things like that. If they don't know what the kid had, that would be a double blind because they'd be blind for the results. Okay, you don't have to list that, but that's something that could be listed as well. Okay, so that's how you would design an experiment with something like that.